Okay, so here's a video for the kind of combinations of being able to graph multiple transformations of sine and cosine. And at the end of the video, I will go back and graph cosecant and secant in with them as well. Okay, so for this first example, it's a cosine curve. Notice that the b value is already factored out from the parentheses. That's really important. So before you identify your a, b, c, and d, you want to make sure that that is indeed factored out. So what I'm going to do here is say my a is 3. There's no reflection over the x because there's no negative there. B is going to be 2, which more importantly tells you about your period. Here your period is going to be 2 pi divided by that b value. So here period is 1. That means that I will see one cycle from 0 to pi, which means this is moving faster than the parent function. C is going to be this value in the parentheses as long as that b is already factored out. So here it is a minus, so that indicates you're going to the right by pi over 2. And D, there's nothing added or subtracted, so there's going to be none, or you could write 0 there. Okay, so what I would do here is first figure out my original period. So my goal is to get my 5 key values, so I'm going to go from 0 to pi, and I leave myself room. Okay, so that's my first key value and my last key value. So halfway between there is going to be pi over 2, and then halfway between those two is going to be pi over 4. So then this kind of shows you're counting by pi over 4. So from 0 you got 1 pi over 4, 2 pi over 4, which reduces. So the next one would be 3 pi over 4, and then lastly 4 pi over 4. So those would have been my key values, except for there's now also this c value to deal with. So because there's a c value that's moving everything to the right by pi over 2, that means that I need to add pi over 2 to each key value. Okay, to each key value. Can you see that? Okay, so instead of being at 0, because I'm now shifting it to the right, I add pi over 2. So 0 plus pi over 2 is pi over 2. Okay. Now the other one that's easy to add to is a pi over 2, because pi over 2 plus pi over 2 is pi. And then you can kind of do the end as well, and then you can find the averages, or you could just add it to each one. So here you'd need to get a common denominator. So I would think of this pi over 2, you could think of it as 2 pi over 4. Right? So if you need to think of it as 2 pi over 4, that's also just pi over 2 reduced. That reduces to pi over 2. So 1 pi over 4 plus 2 pi over 4 is 3 pi over 4. And that makes sense, right? Because that's between pi over 2 and pi. And so then I need to add 3 pi over 4 to 2 pi over 4 to get my next key value. So that's 5 pi over 4. And again, that makes sense because that's bigger than pi. And then lastly, here, I'm basically saying pi plus a half is, 1.5 pi, or you could say 3 pi over 2. So those are my new key values, and that's what I want to put on here. So a general rule is whatever you're kind of shifting by, or you can kind of see like here, whatever your denominator was, that might be a good idea to count by. So I might count like every 2 blocks as a pi over 4. Let's see, if that was a pi over 4, that'd be 2 pi over 4, so that'd be pi over 2. So 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, right? So that seems like it would fit on there. But again, you can kind of adjust it as you see fit. So again, I'm counting every 2 blocks as a pi over 4. So this would be pi over 4. Then this would be 2 pi over 4, which reduces. Okay, so 2 pi over 4 reduces to pi over 2, so that's what I'm going to put here. And then this would be 3 pi over 4. That's just me kind of skipping on. 3 pi over 4. Then 4 pi over 4, which would be pi. And then 5 pi over 4. And then 6 pi over 4, which is 3 pi over 2. So, and that's why it's kind of hard to write them on there because they get squished. That's why I always kind of indicate them there. Okay, so what's important to recognize about this graph is that this distance here is not necessarily consistent with these because this was my horizontal shift. The distance between the key values needs to be consistent, but that horizontal shift may be equal to or bigger or smaller than the distance between each of the key values. Okay, so now that I got my key values, then I say, all right, is there any vertical displacement? No, there's no vertical displacement. So then I'm like, okay, now I need to figure out what to count my y-axis by. To figure that out, you take into account your D and your A. So here there's no fraction, so I'm just going to count one block equal to 1, or in other words, every block equals 1. So that's just my regular 3. And I know that a cosine hits my baseline at the second and fourth key value. And then my cosine starts high, and there's no reflection, so it's going to start high at the third. So the low point is going to be at that third one, and it'll be right there at -3. And remember, a cosine curve starts and ends at the same. So here is my cosine curve. And again, it should be kind of smooth. Shouldn't be able to pop a balloon. It's not pointy or sharp. But there's my cosine curve. Okay? All right. So now we will go on to graph this next cosine curve. And so here, there's a negative with the 2, so my amplitude is still 2, but I indicate that there's a reflection over the x. Remember, your amplitude is always positive. And then the b value, again, there's it's just, this 1/4 is by itself. So that b value is 1/4. What's important about that is that you always do 2 pi divided by the b value to get you your period. So here, 2 pi divided by 1/4 is the same as multiplying by 4. So this is 8 pi. So where this example, that cosine curve was moving quicker, i.e. it was finishing one cycle in less than 2 pi, because it normally takes 2 pi, this one is moving way slower. And there's no horizontal displacement, but there is a vertical displacement of up 3. Okay, so this one, all I need to do is adjust the period. So I go from 0 to 8 pi this time. And this one's really nice because halfway between there is just a 4 pi. Halfway between there is 2 pi. So it's 2, 4, 6, 8. So those are my key values. And again, you can decide on how you want to count those. Since there's no horizontal, I don't know, maybe you skip every other. Maybe you, do it slower, so maybe every 3. But as long as you are the same distance between each key value, you're okay. I'm just going to skip 2 lines in between just so it's kind of nice and spaced out so I can see. And then that makes this 8 pi. Okay. Next, I take into account my vertical displacement. So the vertical displacement here is 3. And I also look at the amplitude there is 2. So there's no fractions there, so I'm probably just going to count each box on my y-axis equal to 1. So shifting it up 3 just means I have my new baseline is shifted up 3, like that. And so then I'm going to say that cosine hits my baseline at the second and fourth key values. So at the second and the fourth, I'm on the baseline. Now normally cosine goes high, baseline low, baseline high, but because of this negative, I'm going to start at my low point. How low? It's going to be 2 below the baseline. So it's going to be at 1 there. And then I have my high point then where I used to have my low. So at 4 pi, I'm going to go 2 above. And then again, you always start and end at the same. So I'm there. And I do my cosine curve here. And again, it's curvy. So we've got that. Okay. All right. So now that you have those 2 graphs, if you wanted to change them to secant or cosecant graphs, that would be the easy part. So to change them into secant or cosecant, I'm actually just going to do it in a different color. Okay, so I'll just indicate that. So if I was to graph y equals 3 secant of that same exact thing, 2x minus pi over 2, and sorry, I got a little cut off there, but if I was to graph this, well, how do you do that? First, you graph this, which I already have done. How clever. And you need to say wherever you're on the x-axis or your baseline, right, that the reciprocal of that is going to be undefined. So that's where you put your asymptotes. Okay. And then you just say, okay, here it's positive, so I need to be going positive and towards the asymptote. Here, I'm negative, so I need to be staying negative, and I'm going towards the asymptote. And again, you're kind of giving it a little kiss at those high and low points. So, and again, here, I have to be positive, and I'm heading towards the asymptote. So I don't know if you could tell the difference. Maybe green was a bad choice. But if I was graphing the green, it would just be these parts. Again, that black would not be there. If you were to graph just the green, I would graph this black, but I would do it really, really lightly in my pencil. Because I just want you to understand that the green is just the graph of the green. You wouldn't actually have that black. For example, if you type this into your calculator, and you'd have to use 1 over cosine to do it, by the way, you would only get this green part. That black wouldn't be there at all. Okay, so same thing here. If I wanted to, instead of a cosine, if I wanted to turn this into secant, okay, of 1/4 x plus 3, then what I'd have to do is, wherever you hit the baseline, you drop in your asymptotes. Okay, here it's below the baseline, so I need to be negative and stay close to the asymptote. Here, oh, this one's going to kind of be bad because it's going to fall off, but I'm going to be like this. And then down here, again, I'm going towards the asymptote. So it's kind of a half of a parabola there. Okay, so you've got that. And those are two examples how you take a combination of transformations on a cosine curve, and then you can also drop in your secant. All right, I will do another video for the sine and cosecant after this. Have a great day.